Hello viewers, my name is Raj and welcome to my YouTube channel. So this is the second video in complete placement preparation series, and today we'll look into a interesting problem of sorting colors. So this is a medium category problem from Leetcode. So this problem is named as sort colors, but simply we can say that it is a series of numbers like between 0, 1 and 2. So we have to sort these arrays such that all the zeros come at the initial, ones come in the middle, and all the twos come at the end. So, but interesting thing is there are some good follow-ups, like we have to complete this. We have to make an algorithm which can use only order of one space, and it should only pass through the array once, and we should get the desired results. So let me first explain you some of the details in the problem. There is a given example. So we will have some like 0, 1's and 2's in the array, and we want to get an array something like this. So in this example, we have 4 initial zeros, then followed by 3 1's and 2 2's. So this is the desired results. So basically, I will try to explain three methods of solving this problem. So first is the naive approach of what we can think of our human brain thinks. So which is basically sort the array and we will get the results. So we will get zeros at the initial and twos at the end. So this, if we use this sorting based algorithm, the average time complexity we will get is order of n log n. Because the best sorting algorithm will give us in average, like in all cases, we will get the maximum time complexity as order of n log n, right? But since if someone of you is using Python, then it might convert up to order of n based on the condition. So condition is like, let's say our our input is good. So in Python they have tried to optimize it to order of n. So in that case it's okay, but since Python has other irregularities, it is always slower than the other premier languages like C, C++. So the idea behind this is only simply like we will sort the array in so after sorting we'll have zeros, ones, and then twos. So this is the first approach. I don't recommend this approach because this is very naive, and it will always, like, you will get the code will get submitted, but I don't think it's a good thing to show in an interview because it seems very it is very written in code, and interviewers expect something more out of you. So let's go towards the next approach. So yeah, this is something like they want, but like it is also not up to the mark, but it is okay. So this approach we'll have to go through the data twice. So it is a two-pass approach, and also we'll be using two or let's say two or three variables. So space-time complexity is not an issue. It is very space efficient. It is always order of 1 in space and order of n in time. So time complexity is reduced to order of n from order of n log n. So this is a good sign, and also the space complexity is reduced to order of 1. But since we are passing it twice, so how passing it twice? So we will basically, since we are only dealing with finite number of unique elements, which is 0, 1, and 2. So what we can do is we can have two or three variables for each of these numbers. So let's say I have a variable which is named 0, and it will count all the zeros, all the number of zeros that are present in the array. And then I will have a variable which is ones, and it will store all the number of ones in our array. And similarly, you can have a separate variable for 2 also. But I think if we go logically, then we only need 2 variables for this purpose. So in the first iteration, we will go through all the elements, and we will count all these variables. And in the second pass, we will just overwrite all the elements using these 3 variables. So that is like a 2-pass solution. So it is accepted and it is good. But what else? So what else your interviewer tells you to convert this 2-pass to 1-pass? They say that I don't want to go through the array once again just for the sake of overwriting. I just want to have a one pass approach, because if they say that we have around 10 million words to process, and if you are going through like each element twice, then it is very expensive in that case. So what if I just go through once only and get the result. So that's why we will go to the next approach, which is the last approach. Yeah, so the third approach is a swapping based approach. So this will guarantee one pass solution, and also it is order of one space and order of n time complexity. So this is like the best approach what we can have. Like it is like this is what the interviewer wants solution, so that he or she wants us to like propose this solution, so that they don't have to do unnecessary operations again and again. So what this approach says is, we will go through the array once only, but we will first of all we will maintain three pointers. So first of all we'll have a pointer which is, let's say, p1, which will point to the initial of the array, and then we will have a pointer 2, which is p2, which will point to the last of the array or the end of the array, and there will be a iterator pointer which is, let's say, we'll take it as I. So what basically these three pointers are. So p1 is pointing like p1 is for basically giving the number of the printing the zeros at the initial at the starting of the array, because we want all the zeros to present at the like initial half of the array. And similarly we will have this p2, which will like print all the 2's at the end of the array. So basically they are pointing that after, like, p2 is pointing that after this particular point we have 2's only, we don't have any other element. Similarly for p1, we will it states that below, like to the left of the p1 we only have zeros, we don't have 1's and 2's. So if we somehow basically manage to get all these zeros at one end and all the 2's at one end, what will we be left with? We will only be left with 1's. So which is basically what we want. That is our solution. So that's what we are proposing. So what it will do is, what this thing will do is, I will basically check for the current element's value. So basically first of all we will check for 0. So if the element is 0, let's say the array name, the name of the array is A. So A of I is 0. Then what we'll do is, we will first of all replace whatever the element we had with we will swap this value with 0 we will swap this value with the p1 pointer, and then what we'll do is we'll increment this p1, and then also we'll increment the I. Okay, this there. So if we do this again and again, what we'll do is we'll simply copy paste all the zeros at the initial. So this may seem vague, but if we take a small example, if we see this example, but if we get this 0, then we will simply put this 0 at the beginning, and we will just increment the p pointer from 0 to 1, right? Similarly we will go through all the elements. Okay, so this was for 0. So if we encounter 2, if we see that this A of I is 2, not 0 and 1. So what we'll do is we will swap this value, this particular element, with the element at p2. We will swap these two values, and then we will decrement the p2 pointer. So what basically this is what we wanted. So basically we are like placing all the 2's at the end and all the zeros at the beginning, and basically we are shrinking the array, we are closing in the range, so that at the end we will only have 1's in the middle. So if we follow this again and again and again, what we'll get is, and also the last case that I forgot to mention. So if A of I is 1, then we'll do nothing, we'll simply increment the I. So this is what, because we want the A to stay in the middle, so we don't change anything, we don't swap with anything, but we only change and swap for values having 0 and 2 value. So if we like try to if you take an example and logically solve it on paper, you will simply notice that we are actually like segregating all the elements individually, and basically it is doing it in only one pass. So if we let's try to code this out. So I'm not like coding all the three approaches because the first code is very redundant. We just have to use the sorting function, and the sorted answer is sorted values are the answer. In the second approach, it is also very like redundant because it is simply counting the values and like overwriting this stuff. But I will implement the last approach, which is swapping based, because it is somewhat tricky. So let's start with the code. So I take p1 as equals to 0, p2 as length of nums minus 1, which is the last value in the list, and then I will have the I, which is the current pointer. So it will always start with 0. So what I will do is I will basically have use while loop for this purpose. I will check if the current pointer is less than or equal to p2 or not. So if the I is greater than p2, then we will basically shut the operation. And what we'll do is we will first of all check if the nums of I, capital I, sorry, is equals to 0. So if this is the case, then we'll simply store the nums of I in a temporary variable. Sorry, I made a mistake. So we will store the value which was at p1, which is at the like initial pointer, and then we'll replace the p1 pointer's value with the current value, so which is 0. So I am like placing all the zeros at the beginning, and then we will basically assign the current pointer as the temporary. So basically it is a swapping of values, and then I will increment the first pointer by 1 and current pointer not like I plus by 1. Similarly, we'll check for 2, which is, let's say, if nums of I is equals to 2, then basically we will again do this same swapping thing, but instead of p1 we will swap it with the p2 value or the value at the pointer p2. So the operation is same, but it's just the the value that we are swapping with. So in this case we will only decrement the p2 pointer. We will not increment or decrement the ith pointer because the value that we swapped from the end is also unprocessed, so we have to process that value as well. So that's why we don't do any changes in the ith pointer, sorry, the current pointer. And then in the end, so we have checked for 0 case and 2 case, but we haven't checked for I. So if for 1, so if the value we are encountering is 1, then we have to do nothing. We just have to increment the pointer because we want the number of 1's to stay at the beginning of the in the middle of the array. So let's run this code because we have to just modify the nums. We don't have to do anything. This code is working fine for the test case, and if we submit this code, yeah, so this is working fine as 90% faster than all the results. So this is I think the optimized code. So you will get all the 3 codes available in the GitHub repository. The link of that particular Python notebook is in the description box, and you can check out other videos as well. So all the links are in the description box, and you can check on the channel page as well. So please like it, share it, and subscribe my channel. And do give your valuable feedback because I don't know if I am doing something which is worth it or not. So please give your valuable feedback, and I will be soon coming up with more such videos. So thank you, and keep learning, keep sharing your knowledge. Thank you, and have a nice day.